Okay, so we have a grade distribution here, and you might wonder why the professor doesn't just give the grades that the students actually get. Well, if you look, the average here is 65, and if you drew out what that would look like, one standard deviation below and above that would be roughly 56 to 74. So you would have 2/3 of the class scoring a 74 below. Probably not the best situation for the typical grading scale. So the professor is adjusting based on he or she knows that we want the top 13% of the students to get an A and then so on. So the question is, what cutoff in a normal distribution, so if you have a normal distribution here, and we want to know what cutoff would give you 13% up here. So what would the actual score be? And in order to get that, it is helpful to first get the z-score. So to get the z-score, we need to know what portion is to the left of this cutoff value. Well, if 13% of the students are scoring A's, that means the rest of them are scoring below an A, which would be 100% minus the 13%. That would give us 87%. So 87% of the students are right here. And if we want to look that up on the chart to figure out, or in the table to figure out what z-score will give us 87% to the left, we'd go the negative infinity to z here. And we're looking in here. Remember, we have the portion, so this is where we'd have the portion. This up here is the z-scores. We don't have that yet. That's what we're trying to get. So we're looking for the closest we can find to 87%. And as we go along here, we find it's in between these two. This one's a little bit closer, so I'm going to pull this z-score. It's a 1.13. 1.13, and I'm going to get out there. But that's not the score itself. It says the minimum score required for an A, it's not 1.13. So here's where we use the formula, and this is the formula for standard normal. We have this right there. So this 1.13 is the value here for z, 1.13, and we don't know what the x is. That's what we're trying to find. That's that cutoff value. The mean we do have, it's 65.1. 65, apologies for my drawing skills here. And the standard deviation we also have at 9.2. 9.2. So this is an algebra equation. We're solving for x. Notice that in order to get x by itself, we first want to multiply both sides by 9.2, and then we'll add that 65.1. So let me pull that over here. I'm going to take 1.13 times, I'm multiplying both sides by 9.2. So that gives me 10.396 on the left side. On the right side, I would still have the x minus 65.1. So I'm going to add 65.1 to both sides, and that would give me an x value of 75.496. It says nearest whole number, which would just be 75. So I'm going to submit that answer here. So just to translate that into plain English, what that 75 means, in this professor's course, a grade of 75 or above would give the student an A, just because the scores in general were so low here. In order to get into the top 13% of scores within the class, you'd have to score a 75 or higher, and that's what this professor has determined would be an A.